Okay, hoping that we have thought at least something. Let's try and think about it. Initially, rainwater was being filled in the bucket at rate R. Now when the wind starts blowing, then the rainwater will no more fall vertically, rather it will acquire some velocity, which will be the summation of 2v and v. It will have some resultant velocity like this. Now this is how the rainwater would be falling, and this is how the bucket is. Now the rainwater no more falls vertically downward. And now if you have to see what is the rate at which the water is being filled, then actually what you have to see is what is the rate with which the water is entering the bucket. Suppose this is the cross section of the bucket. So previously the amount of water which was entering the bucket was through this cross section, and now we have the same cross section of the bucket, but the rainwater is tilted. Now intuitively you can feel that the amount of water which will be entering will be the same. What has happened is just the velocity and the angle of water has changed and nothing else. The amount of water that will be entering the bucket will remain the same. That is from intuition. And if you have to look mathematically, then mathematically how you'll go about looking at is, now the rainwater is falling obliquely. It is not falling vertically downward. It has two components of velocity. Now one of the component is going to drag the water droplet horizontally. Now a bucket will be filled when the rain droplet gets inside the bucket. That means it falls vertically downward. Now this component of velocity is going to drag each water droplet horizontally. Its job is not to fill the bucket, but its job is to move the water droplet horizontally. Now the velocity component, which is vertical, that is the only component that is going to bring the water droplet down into the bucket. So this velocity component is not helping. Only this velocity component is helpful, because this is the velocity component which is bringing the bucket water droplet down into the bucket. This velocity component is not doing the job at all. The job of this velocity component is to drag the water droplet horizontally. And horizontal motion of water droplet has nothing to do with filling of the bucket. Filling of the bucket has to do with the vertical motion of the water droplet. So actually, even though the wind is blowing, but the vertical component of the water droplet is not going to change. So the rate at which the water will be filled will not change. Okay, so the answer would be A. You'll get more of these kind of problem in the exercise. So we'll learn a little more type of relative velocity type problem, and then after looking at those, you go and solve the exercise for all of them together. Okay, now we are moving on. This was in a kind of problem which dealt with rain. Now we are moving on another kind of problem. Suppose there's a river. And you start from one end of at one point on one of the bank of the river, and you intend to swim and go to the other side of the river. Now what will happen if this is the direction of flow of the river? Then what would happen during the course of swimming? You intend to reach at a point just opposite to the starting point on the other side. But what would happen? That would never be the case. That would be the case, but normally that will not be the case. Because if you target to swim straight in water and reach directly on the other side, due to the velocity of the water, you will inherently gain some velocity from the water and you will drift during the course of swimming. So you intended to go in this direction, but actually you have gained some velocity in this direction. So you will be going in this some direction at an angle with the path you initially intended to go on. So actually you will end up here and you will drift from the intended position by an amount, let's say d. So that is how will be the course of one's journey.